Hi everyone. In this lecture series, we are going to see about the DMA controller. Before going to see the pin diagram and architecture of DMA controller, the first thing we have to know what are all the features of the DMA controller. It is a 4-channel DMA. It can be interfaced with the direct memory access. Since it is a 4-channel, it consists of I/O devices and it is designed by the Intel. So each channel we are having 16-bit address and 14-bit counter. It provides a priority resolver that resolves priority of channels in the fixed or rotating mode. It provides on-chip channel logic. It generates a TC signal. For what purpose we are generates a TC signal means to indicate the peripheral that the program number of the data bytes have to be transferred. It generates mark signal to indicate the peripheral that 128 bytes have been transferred. It requires a single phase clock and the maximum frequency is 3 megahertz and the minimum frequency is 250 megahertz. So what are all the three cycles that has been available in the DMA is one is DMA read, DMA write, another one is DMA verify, and it provides an address latch enable, that is address enable signal. It is used to isolate the CPU and other devices from the system bus. It operates in two modes of configuration. One is master mode, another one is slave mode. So here we are having the data bus buffer, which is bidirectional, and it consists of the address bus from A8 to A815. So here it operates in two modes of operation. One is slave mode, another one is master mode. In the slave mode it is bidirectional, in the master mode it is unidirectional. So this is the block diagram, or this is the pin diagram of the 8257. So we are having some of the pins, which is nothing but the data bus buffer along with the acknowledgement signal, hold request, clock. Another one is the data request. Apart from that, we are having the memory read and the IO read. Another one is memory write, another one is IO write. So this is the architecture of the 8257. So the first one is the data bus buffer. It is bidirectional. It is used to transmit the data and receive the data. It consists of 4 channels, where it consists of the data request and as well as the acknowledgement signal. So once it requests the channel in order to send the data, it receives an acknowledgement from all the channels, that is channel 0 to channel 3. There will be a priority resolver which prioritize the channels. Apart from that, we are having the read write. Another one is control logic. So in read write we are having the IO read and IO write, which the input and output data reads and writes, and there will be a clock. It is used to generate the timing signal. The next thing is we are having the reset devices, which is used to reset all the devices. Apart from that, we are having the address bus. So A8 to A15, it consists of only address bus, and the chip select, it is used to select when A0 and A1 will be 000110, another one is 11. So the next one is the ready pin. So the ready pin, it belongs to the read write control logic, where it is ready to accept the data. So if we want to accept the data, the first thing is it has to request whether the data is used to receive the data or not. Another one will be the acknowledgement signal, where the acknowledgement signal sends the signal so that the data is ready to receive. So apart from that, we are having the memory read and memory write, which is used to read and write data. So we are having the TC, that is TC, it is nothing but the terminal count. The function of the terminal count is to check whether the data that has been transferred to receive, or it has been used to receive the data or transmit the data, and at the same time the mark signal, it also be generated in the control and logic. So as I mentioned that we have the data data bus buffer, read write control logic, priority resolver. It controls all the internal read and write operation in the read write control logic. So what happens to the slave mode? If it is in the slave mode, it accepts the address bus. If it is the master mode, it generates the address bus. So apart from that, we are having the control logic, mode set register and the status register. Master mode, it controls the sequence of the DMA operation during all DMA cycles, and it generates the address and control signals. It increments the 16-bit address and decrements the 14-bit counter, and it activates a hold requestment signal on the DMA channel. If it is a slave mode, it is disabled. So TC signal, that is terminal count, to indicate the peripheral how much of the data bytes have been transferred, and it generates the marks to indicate the peripheral that 128 bytes have been transferred. It requires single phase clock, and the maximum frequency is 3 megahertz and the minimum is 250. If it is low, active low, that has been used in the bidirectional control signal. If it is a slave, it functions as an input. In the master mode, it acts as an output line. Thank you.